That's great. Hi, everyone. Welcome to our deep dive call with Index Engines. My name is Kathleen Archer, and I'm in business development here at DPAD, and I'm responsible for managing some of our technology partners, including Index Engines. Some of you may already be familiar with Index Engines. They recently presented an overview of their company and solutions at a Typhoon talk that was held last month. And since that call, I've received many inquiries from the field about our partnership and how to engage and interest in a more technical deep dive, specifically as it relates to legacy backup tape management. Joining us today on the call from Index Engines is Jim McGann. Jim's the VP of Marketing, and Ed Moak, who's the VP of Operations. This call is being recorded, and we'll make it available after the call for replay for you to review or to share with others that couldn't make the call today. And as always, if you have any more questions, please feel free to reach out to me. And with that, I'll hand it over to Jim and Ed. Thanks.
Hey, thanks, Kathleen. I appreciate it. Hey, nobody's on mute, so everybody's open. So if you're going to be doing some work or something like that, mute your own phone individually so we avoid some noise, just FYI. But thanks for taking the time to learn a bit about Index Engines. We have a lot of great traction in the field with providing access to data on legacy tapes. And some of the goals of today is to really educate you on what we've done in terms of the technology, and Ed's going to take you through that, and Ed's going to actually show you how the technology works. There's a couple of players here. On this slide is contacted Index Engines. I'll put this up at the end as well in case you need to reach out to us to get in touch. If you do have questions, feel free to pipe up or interrupt, and we'll try to answer them as we go through this. So, as you know, the challenge with legacy tapes, get some echo somewhere. If someone's on a speakerphone, they may want to mute it because it's getting some back echo on us. But the problem with legacy tape is that all your clients have anywhere from tens or hundreds of thousands to millions of tapes, and they're stored at Iron Mountain or Recall, and it's data that's not really stored on the EMC desk, which is a challenge for all of us. Clients are also facing significant challenge around those tapes, so a lot of the business case we see of getting access to that legacy content is to be able to really manage the costs associated with storing those offline tape assets, manage the liability of the content that's hidden on there, because it does become a legal liability, and for people that have HIPAA compliance or regulatory compliance, it's difficult to manage that content when it's on offline tape. So the solution that we're offering that we're getting significant traction in the field is that we can provide direct scanning of these tapes. So it is different from restoration. We do not do tape restoration. We do not simulate tape restoration of any formats like TSM, even Legato. What we do is we provide a scanning of the tape which indexes the file and email content on these tapes and allows you to search and extract that content off of tape back onto disk. So the goal, I'm actually going to mute folks. So if you do have questions, so if you do have questions, you'll need to doing that now. Okay. Yeah. So I just muted everybody. So if you do have a question, just type it into the chat, and I'll unmute you as well. So that'll avoid the echo. Sorry about that. So the solution is really that we can provide online access to that legacy content. We can extract what's required, and typically with customers, especially with tape, we find that anywhere from somewhere around less than 10% of the content may have some business value or some legal requirements. Getting that off of tape, tape that's sitting in Iron Mountain or Recall or off-site onto EMC disk into an EMC archive to support legal compliance is really the strategy that we've been gaining significant traction in the field. So one of the case studies, and Ed's going to go through a few more case studies at the end, is a global financial services firm, one of the top 5 financial services firm, and we're doing a project in New York and their London location, where they have 220,000 legacy tapes. It's Lotus Notes format and loose files. It's about 18 petabytes of data. We're extracting 212 terabytes of the content that they deem useful is specifically by user mailbox. They have a list of users, about 140,000 users, and extracting their mailboxes out and putting it into an archive for long-term preservation. It's a $4 million plus project, services, hardware, and software that we're doing with the customer over multi-year. So it's there's some revenue opportunities, but there's also opportunity to sell disk and to get that content back online. So what we want to do is take you through specifically how, and that's really the use case that we're really seeing with traction with EMC in the field, and this is the use case that really exists at many EMC customers. So what I want to do here is then pass it to Ed, and he's going to talk about the technology and show you how it works.
Thanks. Again, this is Ed Moak. What I want to do here is kind of take you through the technology at a high level and then actually go right into our appliance and actually go through the workflow on our appliance to do tape remediation. So the traditional restore process is all about creating the original environment, restoring 100% of the tape content back out to disk, going then and indexing that data that's on disk, deduping the results, and searching for relevant data, and then extracting that relevant data, which in most cases is less than 5% of the total data on tape. The Index Engines has an automated approach. So what we do is we eliminate that restoration process. We do direct indexing of the tape content. So we're indexing into the backups, the actual files on the backups, and the content of those files on the backup. After the indexing is done, the user is allowed then to search the index segments that are created and located on the Index Engines appliance. And then when extracting that data, then going back and extracting that data from tape. Again, that same less than 5% of relevant content, but in this case, that's all we're taking off of tape. We're not restoring the entire tape. So with the traditional restore process, 100% of the data is moved from tape to only get to that less than 5% of the relevant data. Where in the Index Engines approach, what we're doing is actually only getting less than that relevant data all directly from tape. Again, all the indexing is direct indexing of the tape content without taking that data off of tape. So for tape remediation and best processes, what we have is a defensible process that we're using in one of the in that job that Jim talked about, the financial services, a defensible process that from end to end, receipt of tape to extraction of data, and based upon the content of the tape, not extracting everything off tape. We're using this automation method to effectively scan those tapes. We can use one-to-many appliances, and I'll talk to you about that. So there is a great deal of scalability within the application. And again, we don't restore content. We do not restore the content that's more than that's just not irrelevant. So we're only moving the relevant content off of tape. The process allows, in the early stages of the process that I'll talk about in a couple of minutes, the ability to quickly cull that tape content. Look for blank tapes, look for corrupt tapes, look for tapes that contain backups with non-user data, maybe application system files, tapes that are out of the date range for remediation. Looking for tapes that may have databases or unstructured files that are not useful for remediation, and getting rid of incrementals versus making a decision whether you want to process incrementals and fulls or just the fulls, eliminating a lot of redundancy. We extract that relevant custodian data directly from tape into legal hold or onto EMC disk. We maintain the forensic integrity of each of the files. We're extracting out the native files from the backups, maintaining all the key metadata components for each file. Undo that. And using an extraction method by just extracting those files directly from tape without the restoration. Just looking at some of the chat stuff here.
One of the questions that came in is, can the products use the backup application catalog to avoid the scanning step?
And the answer to that is yes. We have two options for the cataloging operation that I'll talk about when we go through the actual demo. But we have the ability to actually, if you have the catalog on hand, we can ingest the tape catalog into the server, eliminating that first step, and allowing the customers to actually then use the search engine to be able to decide what tapes they want to index based upon the backup properties, based upon even the file content, the file level file listing within the catalog.
Well, the other question is, who is the provider of compliance archiving from EMC? When we extract the data from tape, it comes out in its native format, either email, MSG, or documents or PowerPoint spreadsheets, whatever it is. So we can get ingested into any archive. We don't directly ingest into Source1, for example. Not today. It's something that we can definitely look at in the future, but we're going to extract it out to disk.
Okay. So again, going through this automated tape culling process, first step is to inventory the tapes, and this is really around that documented process, that legal process that we've got implemented in the bank in New York City. There's an inventory process where there's a visual inspection of the tapes. The tapes are logged. Generally 2% of the tapes are then flagged at that point in time and taken out because they're either damaged, mostly damaged tapes. We then go through the cataloging process, and I'll talk more about that and exactly what that process is and what information is gathered in that process in a couple minutes. But during that cataloging process, we can then find those tapes that may be unreadable, media errors that are just bad tapes, tapes that may have a backup format that's very old, that's unsupported, that really nobody can read at this point in time. Being able to pull that out, that gets us down to about 90% of the total amount of tapes left to be processed. Using that catalog information that we gather in the catalog, we can then do further culling of the tapes, get rid of those irrelevant backups, backups that may be backed up in a date range that's out of scope of the project or the remediation policy, tapes that are non-useful data. So taking that out, and that's a significant reduction in culling process, getting down now to about 40% of the tapes left for actual indexing. So a tremendous amount of tapes have already been culled, and we haven't even indexed a single tape, just utilizing that catalog information. The remaining tapes then go through full indexing, where we'll completely scan the tapes. We dedupe the data that's on tapes. We see at least anywhere from 90 to 98% of the data on tape is redundant, especially when you're looking at large numbers of tapes and backups of the same servers for weeks and months and years at a time. We utilize an automated library, so this is really a hands-off process. Talk a little bit about that in a little bit and show you that process on our server. So that deduping, that denisting, getting rid of, now we're down to 20% of the starting data is now still relevant in the process. Now we can go through and run a set of searches, identify the custodial data that we need, tagging that data, and then identifying that data for extraction from the tape. So up until now, no data has really left the tape. We've indexed the tapes in place, created an index segment that is located on the index engine's appliance, been able to search that data and tag the identified data that we deem relevant at this point. Now we can extract that 5%. Going back now, we're only extracting that 5% of data from tape, maintaining that forensic integrity, and that's key to this whole process. We're not manipulating any of the metadata for those files, and getting that relevant data off tape. At the end of this, the user has the ability then to deem all the key information is taken off the tape. They can recycle the tapes. They can go and destroy the tapes, as with our customer in New York City. So we've got an automated process here that starts out with large numbers of tapes, being able to identify that small 5% of data that is on those tapes and extracting only that 5% of data out to disk, and being able to then remediate the rest of that tape. And again, this is all without the need for the original backup catalog, the original backup software. We don't have to replicate the original environment this was on. This is all done without any restoration or the need for that original backup software. So again, the tape remediation project, it's a standalone process. It's not integrated with the production network. So this is generally done in a separate environment, away from the production network, so we're not interrupting the standard backup processes. The people that can run this process are low-level tech resources required to be able to load tapes, manage tapes. It's a pretty automated process, and there's no need for that legacy software. The resources you're going to need above the Index Engine's appliance or appliances, depending upon the number of tapes and how fast you want to get through the project, is simply a dedicated tape library for each appliance. That library is going to be the automation is controlled by the Index Engine's appliance. And as I mentioned, we can scale to meet all different types of time frames. If you want to go faster, large numbers of tapes. If you want the job to go faster, it's simply a matter of adding additional Index Engine's appliances, adding some tape libraries to increase the overall processing throughput of those tapes. And then extracting that data stored on the tapes with forensic integrity onto a repository, could be for example, EMC disks or an archive that resides on an EMC platform. The expenses of really doing this are the manpower, and again, it's junior level people, non-dedicated resource, tape libraries dedicated to each appliance, and the Index Engine server using our per tape processing license. And if you're using the Index Engine's archive, which again, our archive can reside on EMC disk as well, that license as an option. So just a couple of jobs that a couple of examples of projects that we're working on now. The first one Jim talked about earlier. It's a large financial institution in New York City. They've got actually a couple of million tapes at their disposal. Our first project is 220,000 tapes, about 18 petabytes worth of information. We're utilizing 33 Index Engine's appliances and 33 tape libraries to be able to, actually 35 tape libraries, and 33 tape libraries and 35 Index Engine's appliances to be able to process those tapes. And we're getting average throughput of about 5,000 tapes per month. Predominantly, these are old versions of tapes. So we're working with old DLT4 type technology and SDLT technology here. And being able to gather about 130,000 custodians, all the emails and loose files associated with 130,000 custodians, and that query for that is about 1.6 million lines of query. Doing that, this is a multi-year project with them. We've got another customer. It's supporting their legal hold process. They've got about a petabyte worth of Exchange backups, backup to disk, NBU backup to disk files on data domain. We're indexing all that Exchange database and extracting and putting into an archive back on the data domain about 1,300 all the emails associated with about 1,300 custodians. So we're taking that 1 petabyte of Exchange backups, and we'll end up with about 10 terabytes of archived information for that particular project. We get some other projects here. This was a litigation project, more of an e-discovery type project. But again, there were 1,900 tapes with Exchange and loose files on them, about 95 terabytes. Primarily DLT and LTO. We used 3 engines with 3 tape libraries. Took us only a couple of weeks to be able to process these tapes and be able to extract all the email or data associated with 53 custodians, 300 gigabytes. So we had 95 terabytes of data on tape, and the only data we removed from tape was about 300 gigabytes for those 53 custodians. That one took about 4 weeks to get to a point where we can search. Question, is there a virtual appliance we could run as a VM guest, assuming the guest had fiber channel connectivity to the library? Right now, Index Engines, the appliance runs in two flavors. One is on a virtual appliance and a standard 2U hardware-based appliance. Currently, the tape processing is only done on the Index Engines appliance, the 2U hardware appliance. Tape processing is not available on the VMware Guest at this point in time. That's only used for indexing LAN-based data. So you can use the virtual or VM machines if you're going to be indexing disk files, backup to disk files on the LAN. You can use that VMware appliance to be able to process those files. Going to go jump into the demo at this point in time. So the environment that we have here is we have an Index Engines appliance at the center of our demo configuration. Again, it's a relatively small footprint in the overall architecture. The 2U 19-inch rack-mountable server. That single server is able to index and make searchable about 100 terabytes worth of information with the onboard memory and the onboard disk on that appliance. We can expand the capabilities of a single appliance by utilizing locating the index segments on external disk, or we can increase the overall throughput and scalability of the project by multiplying the number of engines and tape libraries with that in that environment. So right now we have connectivity to a tape library as well as to NAS storage and desktops. Access to the appliance, both from the administration and the search side, is via standard Windows GUI browser. So, any additional questions at this point? And if not, I'm going to launch into the to the demo. Just real quick before I do that, contact information within the Index Engines again if you missed it earlier on. Okay, let me just go over to our demo machine here. I'm going to launch the browser. Let's just sign in. So again, interface to the appliance is through a standard Windows browser, Internet Explorer, Firefox. So let's start with, I want to walk you through the actual workflow of doing a tape remediation project. Overall workflow is really, getting some questions in here. Main backup out. Okay, so the question was, if the customer replaces his main backup app, why should he buy your product instead, just staying with the downsized old backup system? So for backup migration purposes, the reason to go to Index Engines is you can eliminate the need for that old backup media system. So you can migrate your tape catalog to the Index Engines appliance and be able now to have access to that legacy data on old backup tapes and not have to pay for the maintenance contracts for your old backup application, the people to run those backup applications, to know those backup applications, and the resources to run those backup applications. So you can rid yourself of the resources, the maintenance contracts, and even the people, the dedicated people to run those, and they can be pretty pricey, especially with some of the backup applications, for example, TSM, and be able to use the Index Engines appliance now to get access to that the data that's on legacy tapes from a single place. So, first thing to do on the Index Engines appliance is really it's a two-step process for three-step process for tape remediation. It's all about indexing the tapes, actually cataloging the tapes, and then indexing the tapes. So in the environment, what you've got set up, what I've got set up here is an Index Engines appliance. I've got a dedicated tape library, so a library with a media changer and 4 tape drives associated with it. First thing I'm going to do is just load that tape library with the tapes to its max, close the door, and the Index Engines appliance will then work with that library to then start the inventory of the tapes in the library and the cataloging of those tapes in that library. That cataloging process is generally pretty quick for most backup applications. anywhere from 5 to 10 minutes per tape, and we can catalog on multiple tape drives at the same time. What the information that's gathered during that cataloging phase, that first pass, is the following. We'll gather the internal label ID for each tape. It's written in the header of the tape, so we're reading that tape header, when that label was created, the barcode of that tape, the internal ID if it's available, whether it's in the tape format. This happens to be a Legato. Backup applications we support are Legato, Veritas Net Backup, ArcServe, Commvault, MTF or Backup Exec, TSM, UltraBack, and HP Data Protector. I think that's about all. And we're always adding backup applications as we go on. So we gather that internal header information for each tape, and then the backup set header information for each backup set on the tape. So the backup set ID, the time of the backup, whether it's a full backup, an incremental backup, a differential backup, again, the backup format, the host type, whether it's an Exchange backup, Exchange agent backup, a Windows agent backup, a Lotus Notes agent backup. I think I have even an Oracle agent backup in here somewhere. So the backup, the host type, the host that was backed up, and then the root path if it's available. So this is the information that's going to be used for that first pass culling information. Now all this information can be put into a CSV form. If I select all the tapes, generate a catalog report, I can look at all this information in a CSV report that can be imported then into an inventory database, into any kind of database program to do that, help with that culling information. So each backup set is a line item in the report, giving the tape label, when label was created, the barcode, all that relevant information, including the backup set ID, the backup time, the backup type, and the backup format. So most of our customers have remediation policies, and this is the first pass of taking that policy and identifying only those tapes that apply to that policy, being able to cull out a significant portion of the tapes, whether it be by backup time, whether it be by the host type, or even the host that's backed up. There was another question here, and let me get to that question. How do you ensure the customer that you really have all this relevant data and you haven't missed anything or thrown away anything that is important? All the data here is in the cataloging operation is displayed on the screen. If there's any problems during the cataloging where we missed anything, and I don't have it up here, but there's a place where we would present errors information to the user. In addition, there's a tape pass. So for each backup set that was on the tape, if there were any problems indexing that backup set on that particular tape, you would get that failure identification here with a reason code for why that backup set was skipped or why that backup set wasn't fully processed. Could be because of an I/O error on the tape. Could be because of a missing tape in a tape set. That'll all be identified here within the pass information. There are other reports as well. For every time a tape is touched, there's a detailed tape processing report that you can also go to as well. So if a tape went for a pass or an indexing pass that failed, there's actually another report that is generated that can be downloaded in CSV format. So once the tapes are cataloged, the culling is done based upon the catalog information. The user then has the ability to select tape or tape sets for indexing. We have different ways to be able to filtered the tapes so that they can see only the tapes that are accessible in the library for the particular engine that they're working on. They can identify all the complete tape sets so they can be easily selected as in whole. But all they have to do is actually select the tapes that they want for indexing, and then start that indexing process. Again, pretty hands-off process. We're going to go and tell the library which tapes to put in the drives. We're allowed to index in multiple tape sets at the same time using multiple tape drives in the library. We can watch the ingestion status. We can monitor that process. In this case, I've got those 4 tape libraries and tape drive 3. I'm indexing this net backup tape, so I'm indexing that Lotus Notes file and the emails within inside that Lotus Notes file. You saw some levels there. That particular email had a number of zip containers attached to a particular message. We're actually indexing into the attached zip containers and the zip containers that were in that zip container. So we do nesting of zips within inside of zips, containers within inside of other containers, compressed containers. In this particular case, we're indexing that Exchange backup on that Legato network. This is an Exchange agent backup, indexing all the emails within that Exchange backup, the full content of each email, the metadata for each email, and indexing the full content of each attachment within the email. The culmination of this indexing is an index segment that is located on the Index Engine's appliance. The index segment is generally 4 to 8% of the total data we index. It's a highly compressed, highly efficient index, one of the most efficient in the marketplace today. That allows us to be able to search up to, process up to 100 terabytes worth of information on a single appliance. So in this case, we're wrapping up the indexing here. That index segment is then built, and let me go over and show you a segment report. The segments, this is the segment that's being built. I indexed a couple more earlier today and yesterday. So I indexed all the tapes in my library in a single pass. So here are all the backup sets that were indexed. Indexed about 21 gigabytes. Took me about 3 minutes and 14 seconds. So I was indexing at an average speed of 119 megabytes per second. That's across all 4 drives. I can see a total amount of data that was actually indexed and the type of files that were indexed in this particular segment. So we break this down into the file type. So here you'd see I've got 6 Exchange databases, 57,000 Exchange messages. I've got some corrupt messages, and the reason they're corrupt is there was one tape where there's a span backup. So the Exchange backup goes across tapes, and I don't have the second tape. Strictly for the purposes of this demo to show you that we do pick that up. We do show those errors. That Exchange backup, that span, we're going to index everything we can on the tape that we had and make that searchable, make that available to the user, but showing a status flag of corrupt or missing data because some of the messages, the attachments or the body of the message may have been on that span tape that we don't have. Got a number of other messages, other files here that were loose files, attachments to emails, and so forth. For a total of about 213,872 files were indexed across those tapes on that segment. At this point in time, it's that 2-step process. Very little hands-on work other than loading the library, arranging tape sets, closing the door of the library, and just letting the system run. Catalog the tapes, identify the tapes that you want to go into the indexing process, select those tapes, and then start that indexing process. At this point, we're actually ready to start the searching process, to identify the data we want to take off of tape. And I've got another question here. Is there any tape technologies, AIT, IBM 3590, or tape libraries not supported? Actually, we'll support any tape technology or tape library that can be connected to the Index Engine's appliance, either via a SAS connection, fiber channel connection, or a low voltage SCSI connection. So yes, we do process AIT tapes, 4 millimeters, 8 millimeters, the 3590, the 9940Bs, and all the standard DLT, SDLT, LTO technology tapes. The only tape technology that I know we don't support is the old 9 millimeter reel-to-reel type tapes. Haven't seen any of those around in a while, but I'm sure they're out there. So we process the tapes. We're ready for it to identify the data that can be taken off of the tape. So we can go over to our search interface here. At the start of the project, we set up, the question was, do we support ACSLS type libraries? That supporting ACSLS is on our roadmap, and we are looking for one of the first partners to actually to really cause us to implement that. We've looked at it. We know we can support ACSLS. We just haven't done the work yet, and it's really based upon prioritization for our first customer. So setting up the user preferences for the first project, what fields I want to see in the various reports that I'm going to generate across the project. These are all metadata fields. So whether I want to see the BCC, the CC metadata information for emails, the documentation document class, Microsoft defined document class, whether I want to see the creation time, and so forth. Setting those fields, saving those fields in my preferences, setting up how I want to deduplicate. So let's talk about deduplication a second. During the indexing process, we calculate an MD5 signature for every file that we index. So an MD5 signature, and we use that signature for content-based deduplication. So now I can select how I want to deduplicate my search result. We're going to deduplicate at search time. So we're going to select by deduplicating by content, by path alone, by content and path, keeping files within differing owners, keeping files within different families, being able to set up our deduplication policy here on the server. Once I've got that set up, I'm ready to start my search process. So the search interface on the right-hand side, just a tour of the search interface. The right-hand side is all our search results and our report section where we display the results. The left-hand side is all about generating the actual searches. And I have 3 ways to generate searches. I can generate them using our filters capability, kind of like a query builder. I call it a query builder on steroids because you can really develop a pretty complex set of search terms. Being able to do content-based searching, all the standard Boolean operators, and, ors, nots, nears. So being able to search on within documents by the word confidential. Do near-based searches, proximity searches, security, and threat, and being able to run and develop and run those searches, and you can see how quick those searches run across my data set. So by content-based searches, I can search based upon the file-level metadata properties, the path, the file name, file owners. I can do ACL-based searching. This is mainly for when we're connected up in a LAN-based situation where we're connected and integrated with the Active Directory, the customer's Active Directory. Now I can resolve the SIDs that are on the backup tapes. If I'm connected to Active Directory, I'll resolve those SIDs that are on the file system during backup in the backups and resolve them to the owner names on the Active Directory. I can do searching based upon the document level metadata properties, so the internal title, the author, created, modification time, and if I'm dealing with email, based upon email properties by subject, from, to, CC, BCC, the send time, receive time, so I can date range my searches as well. So being able to produce a search terms using the filters capability. The second way is actually typing in the query itself or cutting and pasting in a query that you've created offline, being able to and then edit that query. This is the confidential and implied and security within 20 words of threat. And being able to save that query, and this is important for as I get on to the end about automating this process, about saving the queries for use later on. The third way of searching is searching via locations. So we remember the location of the host that was backed up and the location that was backed up within the tape backups. We'll identify those hosts that were actually backed up, and now the user has the capability. The user has the capability to actually go into a specific host and identify and drill down and say, I just want to search within for all the data on a specific host, or all the data on a directory within a host. So being able to go into this Exchange database, identifying the actual owners within that Exchange database, the mailboxes within that Exchange database, and being able to select a single mailbox and search on that specific mailbox. Again, so I ran this back to the search. So I ran this confidential and security within 20 words of threat. The results sides, I'll see the individual results. At any point in time, I can go in and look at a specific result and see the reconstruction of this happens to be an Exchange message. See the object level metadata, the subject, from, to, sent, received, the document class type, the file level metadata, where it was an Exchange message in a John Doe's mail inbox, and being able to see the content of that email message, all the words in the correct order, with punctuation, without capitalization. So being able to see that and then also identify the words that were hit, highlighted by my query tone. So security within 20 words of threat, and somewhere in this document I've got the word confidential. So I can see my results in the forms of individual results, but I can also see reports of that result. So we're going to rerun that search and generate a set of graphical reports summarizing the query results from that specific search. And I can also use these results to do further culling on the data itself. So what we do here is we actually have to rerun that search, and then we're going to compile those reports. And why this is running, if anybody's got any additional questions, I can take them now if that's possible. Okay. So other settings while this is running as well. At any point in time, so I have the ability to do regex operators, so I can do wildcard-based searches, POSIX-based searches, POSIX extended searches. I can show right now my deduplication is on, so I'm showing only the unique objects returned from that. If I want to at any point in time, I can essentially turn deduplication off and show all, or just show all the duplicates, eliminating removing the unique objects from the results set. So several settings on that side. Back over to the results of our search. So I search that database. I can generate this happens to be a file type report. So the types of files will give the nominal size and the number of accounts. So there's 443 PST messages that were responsive to that search. Where that data resided, the data resided all on the 192.168.17.101 server. I can see who the owners were of those email messages, primarily John Doe, Adam, here. Again, another form of another email called John Doe, and so forth. I can see modification time, access time data for the results. For each of the results. So, and again, I can actually do culling with. So I can go back to my owner report, say I only want to see all the emails responsive to John Doe, and now I can further cull that data down directly from the summary report. Get to this question that came in. Was there a new question? No, I guess not. Okay, so being able to further call that down, and I can go back over and see the result of that in my query. So confidential and security within 20 words of threat, John Doe, and so forth. So there's a search capability, the reporting capability. I always have the ability to be able to select individual or select all the results, being able to provide a being able to download the CSV for that particular set of reports. So this is a report for each individual results and all the metadata for each result, as well as, for each result. I can also tag the data, so I can add tags to my data and say this is my extract one, and tag and put a tag on each of these individual items, the extract one tag. I can then further search within a tag or exclude data that contains a tag. And items can have more than one, many different tags associated with this. So there's all the capability. And then what I can do is actually go and extract that data directly from tape. So here's the last part of the process, is being able to go in and extract that data out to disk, being able to identify, give it a description, tell it what format I want the email messages to go into, EML or MSG, put them in MSG, and give it a destination path of where I want that, give it the destination path on disk where I want that data to go to, 192.168, 17. My destination, give it my username and password. And start that process. So we started job 7. You'll see here that we're analyzing the results. What we're actually going to do is identify the smallest number of tapes. That's just minimizing the smallest number of tapes that will produce all those files that I selected. And we're going to start to 207 files, and we're going to extract those 207 files out to disk. So we've indexed, we've cataloged, we've indexed. And now we're just extracting that small amount of files out to disk from those tapes. I can then go and see those files out on disk, the 101. Oh, it's 250. I'm sorry, wrong server. There's a 250, and this was job 7. And there's my data. So there's a summary report for each individual file that's extracted out from tape. Again, with all the user applicable data, so the requested path name, the destination path name, and the various other metadata components. Part of the validation step for this process, and the data is then taken out, written to disk in the same directory structure that was backed up on tape, collection of PSTs, and here are the individual items. John Doe's PST content was in the top in his inbox. And there are some of those email messages in the same forensic format that it was within John Doe's PST that was created. Now, I went through this process in a very manual form, and I'm going to wrap up real quick here. There's an automated way of doing this. When we're doing this out in that financial firm in New York City across 33 machines, we're not doing this, by hand. We're taking our policy. Our remediation policy, we're taking that and creating that policy in a query. In that case, there was actually 40-some queries that were created. We're saving those queries as saved queries. So we're saving each of the policies in our saved query, and then we have a capability called action queries. So the cataloging index happens. When that's done, the user is notified. The user then launches what we call an action query. We take those queries and we put them in an action format so that they can be run all automatically at one time. The action queries, I can create a description. I can say run the saved query that I created. Put my policy in. So put my my policy in. tell it I want to take this action. I want to add a tag to the results, add the tag I want, the extract tag, and then submit that. And what I can do then is then run all those in one big bunch. So I catalog, I index, I hit the button to run all my queries, tag all the data. When that's done, I simply extract that data out to disk. Extraction across many machines. We do another round of deduplication. So I'm actually going to deduplicate. If I'm running 2 or 30 machines, in the case of the customer in New York City, if I'm running 30 machines, on extraction time, we're going to utilize an extraction database that we actually say we will look at, has this file been extracted? If it hasn't, go ahead and extract it and add the signature to the database. So we do a final round of deduplication at extraction time for these large processing jobs. So, any questions at this point?
Actually, we're running short on time, so if you do have questions, there's a bunch of contacts here from Index Engines. This has been recorded if you want to share it with other folks. In terms of any question, one of the best contacts on here is John Alcorn. You see him on the bottom. He's managing the field engagements with EMC. He could point you in the right direction, get you the resources that you need. If you have specific technical questions, Ed Moak did the presentation, VP of Operations. He can address those for you. We also have one of the things that we didn't show here is we have an ROI analysis calculator that Ed runs, where we can work with you on your customer sites, where we can analyze their tape environment. And in a lot of cases, we can show that the cost that they're spending to store data out at Iron Mountain, for example, could be less if they remediate the tapes, recoup that ongoing annual cost, and move the data that they need to disk. So it's not moving everything to disk, which is just going to take way too long, but it's deduping it, finding the data of value, and moving that onto disk into, say, a Source 1 archive or a data domain box or Avamar box for long-term preservation. So if you do have questions, we can go through this ROI analysis. We can engage with you directly. Email addresses are on the screen there, and through Kathleen, we can get you also a copy of the link for this recording. We can also get you a copy of the presentation. There was a lot of details in there as well. So there's a few questions we're not going to have time for. Unfortunately, we have to jump on to another presentation. But hopefully that was informative, and we thank you all for your attention this afternoon. Thanks.